Alright guys, welcome to this page of the notes. What I'm going to try to do here is tie everything that we've done so far in this note set, these set of videos together for you, talking about relations, functions, is a relation also a function, and then how do you go ahead and graph these things. So let's take a look at this problem. I'm asking you to graph the relation given by this equation. I want to know, does that relation represent a function? Find the domain and range, and is it discrete or continuous? Well, right away, we can answer the last question, is it discrete or continuous? We said anytime you're given an equation, it will be continuous. So that takes care of that part. But in order to graph this guy, well, I'm going to need to set up a table. But before I can set up a table, I need this equation to be solved for y. I need the y all by itself. That way I can plug in values for x, do my math, and figure out what y is equal to. So let's take care of that first. I need to solve, oh, that's my highlighter. I need to solve for y. Alright, so let's do that. I have 2x minus 4y is equal to 8. Alright, first thing I'm going to do to get that y all by itself, I have a positive 2x. Let's move it to the other side by subtracting 2x from both sides. So I will do a minus 2x and a minus 2x. The 2x is on 2x. The 2x is on this side, plus 2x minus 2x. They'll cancel each other out, and that'll leave me with negative 2x plus 8 over here. So a minus 4y is equal to negative 2x plus 8. Okay, now in order to get the y by itself, I'm going to have to divide both sides by a negative 4. So let me go ahead and divide everybody. That guy gets divided by negative 4. That guy gets divided by negative 4. That guy gets divided by negative 4. Everybody gets divided by negative 4. Let's see what we're left with. Well, y is going to be equal to, here we go, negative 2 divided by a negative 4. The negative signs will cancel each other out, and a 2 over 4 reduces to 1/2. So we'll have 1/2 x. And then, of course, 8 divided by negative 4 is going to be a negative 2, so minus 2. There we go. I've now solved the equation for y, and now we can set up a table. Let me make this quick note. For those of you who remember from Algebra 1, yes, this is in slope-intercept form. Y equals mx plus b. If you would prefer to graph it using slope-intercept form, please feel free to go ahead and do so at this point. If you don't know what I'm talking about, or you're like, oh, I think I remember that, but I'm not really sure what to do, don't worry. It's coming at a later section in this chapter. We'll get to slope-intercept form, how you write it, how you graph it. For now, I just want you to use the table, right? That's plenty good enough for us at this point. Remember, the way the table works is I need x values. I'm going to choose my x values. I'm going to figure out what y is. Work smarter, not harder. I'm going to pick these numbers because they're easy, not because they're better. So here's negative 2, negative 1, 0, 1, and 2. All right, those are the values that I'm going to plug in for x. Here we go. Let's do a little mental math. I plug in a negative 2. Well, 1/2 times a negative 2, the 2's will cancel each other out. I'll be left with a negative 1. Negative 1 minus 2. How about a minus 3? Do it again. Negative 1 in for x. 1/2 times a negative 1. Well, anything times 1 is itself, but it's a negative 1, so it'll be a minus 1/2. Negative 1/2 minus 2 should be a negative 2.5. Okay, let's keep going. I plug in a 0. 0 times anything is 0, and 0 minus 2 should be minus 2. Let's keep going. I plug in a 1. Well, 1 times 1/2 is 1/2, and 1/2 minus 2 should be a negative 1.5. Okay, I plug in a 2. Well, 1/2 times 2, the 2's will cancel each other out. So that'll leave me with a 1, and 1 minus 2 should leave me with a -1. All right, now I have a bunch of points that I can go ahead and plot. Let me plot them in red. Make sure my dot is big enough. Here we go. Up first, I have -2, -3. 1, 2, 1, 2, 3. And right there's my dot right there. -1, -2.5. -1, -2.5. It's going to be right about there. No, hang on. Missed it. I missed it. Right? There. Yeah, okay, that's better. 0, -2, 0, -2, right about there. Oh, that'll work. 1, -1.5, 1, -1.5, right about there. Yeah, that'll work. And 2, 1, 2, -1, right about there. Yeah, that'll work. We'll take it. All right, so remember we said it was an equation. This has to be continuous, so we're going to connect those points with a straight line. Make sure you go all the way through the coordinate plane that I've given you. End your line with arrows so that I know that you know that keeps going to infinity in that direction. It keeps going to infinity in this direction. We've used our table to plot our line. The last thing I asked you to do is figure out the domain and the range. Well, the point here is this. This arrow keeps going to infinity in this direction. The arrow keeps going to infinity in this direction. So let's talk about the x-axis. Are there any values of x that you could not plug into this function? The answer is no. You can plug in any number you want to. So for the domain, it's going to be all real numbers. All right? Pick any number from 1 to infinity that you can possibly think of. You can plug it in for x. Now, what can you get out? Are there any values of y that you're not going to get? Well, please just go ahead and look at this. Please notice on the y-axis, right, my red line just keeps going down and down and down and down, which means it's going to keep going down and down. Up here, it just keeps going up and up and up and up, which means that all of these values of y are also covered by my function, which means that no, there are no values of y that are not possible. I could get anything for y, which means that my range is all real numbers. All real numbers, right? There's not a single value for y that's not possible with this function. Everything, I could get any value for y that you could possibly imagine. Everything is possible, so all real numbers. That takes care of the problem on this page of the notes. We have one more page to go, so head on over and I'll meet you there.